This is Joel, and in this video we'll start discussing a little bit of BGP with IPv6. Okay, cool. So what have we done? If you have been following this whole series, right, we have been playing around with IPv6, and the very previous video kind of talked a bit of general IGP routing protocols, right? So we pick a pen here. Yeah, so what we did was we kind of did RIP over here, right? We did RIP ng, okay, and then I remember we also did EIGRP over here, didn't we? Right, so in this segment we actually did EIGRP over IPv6, right? Then we also looked at another very important protocol, which is your OSPF v3, right? So over here in this segment, right, OSPF v3, we also did it here in this segment, we did it on this segment, and we did it here as well, right? So yeah, OSPF over here, EIGRP over here, and RIP over here. Okay, so today we'll concentrate on what BGP, right? So for BGP, do I have more colors here? Probably not. Okay, so let's probably pick black, right? So for BGP, what we're gonna do is so we are gonna try both eBGP and iBGP, right? But then BGP is kind of little interesting when we talk about IPv6. The thing is, what they have done with BGP is that they have just added a new address family to support IPv6, right? BGP is flexible that way. Remember when we did MTBGP, we just had to introduce a new address family, which was the VPN v4, right? Because the size of the routes increased from your 32-bit to 96-bit, and as a result, we had to basically add a new address family. And then remember, we had the whole route distinguisher and route target and all of that, right? So basically your BGP is very flexible that way. That is, you want to add more different, you want to do eVPN, you want to do VPN v4, you can just go on adding address families. So IPv6 also is handled in this very same way by adding a new address family, right? That means that your BGP, your underlying BGP can run either over IPv4 or over v6, right? So I mean, till now we have obviously seen how we can run BGP over v4 in probably a lot of use cases before, but now that we're talking about v6, the underlay can be either of them. You can either use v4 or you can use v6, right? It's and then depending on, I mean, whatever you use, right, based on your constraints, right, you use whatever you want. But then on top of it, right, for exchanging the routes, right, you can again exchange any of the address families, right? Again, you're not stuck with something specific. It's not that if you're using v4 for building the neighborships, you have to like exchange only v4 routes. No, right? The underlay can be v4, v6, and then on top of it, you can exchange any address family, right? So that's about that's the kind of flexibility which your BGP brings to the table, right? So now in our today's video, we're gonna, like I said, we're gonna talk about BGP. So let me probably pick black, like I said. So we are gonna do both, right? We're gonna do iBGP and eBGP, right? And obviously we'll talk about a little bit of interesting issues which creep in when we talk about things like next hops, because now we are going to be running a lot of different combinations, right? You might be running v4 in the underlay and then trying to exchange v6 routes, or you might be running v6 in the underlay and trying to exchange v4 routes, and a lot of combinations. So there will be a bit of next hop issues which will come into effect, and we'll probably try to tackle them as we go ahead. Okay, so our topology for BGP is going to be nothing but so we're going to have this whole thing in AS. This whole segment over here will be basically in one particular AS, say AS 100 probably, right? We can go with the AS 100 here, and your other AS will be here, right? And that's going to be in AS say 300. Right, so that's what we have. So we will obviously target whatever we are going to be doing here in between. This will be eBGP, right? Because you're talking between two different AS, and whatever you're going to be doing inside, we are going to be That's going to be iBGP. Okay, so let's get to it. So I'm going to hide the screen and get to my secure CRT so that we can start with the configurations. Yeah, let's get started. Okay, so we'll start with where? What's our starting point? We'll start with R3. Okay, so we'll do eBGP between what? R3 and the switch 3. Okay, so let's get to probably R3 here and do show CDP neighbors. And let's also see what is the current situation with IPv6, right? So let's do show IPv6 interface brief. Okay, this is what we have. So looks like your R3 is connected to switch 3 on Ethernet 0/1, and if you go to Ethernet 0/1 here, this is the link local and the global address, right? Cool. So let's start with configuring BGP here, right? So we'll say router BGP, right, and the AS number is 100. So the very first thing you gotta do is, what is the neighbor? So in my case, the neighbor is, you're going to be peering on what? On the global addresses here, on at least in this example, right? So yeah, so you have the neighbor, and so this will be the neighbor address, right? I mean 39::3 is my address, but obviously on the switch 3 side, if you see here, show IPv6 interface brief, it's going to be what? It's going to be 39::9, right? So this is literally the address which we'll be using. So let's actually grab it from here to avoid confusion, right? Yeah, it's the same thing. Yeah, so there you go, right? So you grab that address, that's the neighbor, and then you gotta put the remote AS, right? What's the remote AS? It's 300 because it's eBGP, right? That's why this is different. This is 100, this is 300 over here. So once we do that, what is going to happen? Do you think that is it? No. What you also need to do is you need to enable the address family, which is IPv6 unicast. By default, the address family for BGP is IPv4, right? So you need to explicitly enable this, and you will have to get into the address family and activate this neighbor, right? Now that you do that, you can also go and check here, show BGP IPv6 unicast. And do we not have anything yet? It's not that, right? Because we haven't brought up the neighbor, right? But one quick way to check if, let's actually first check the BGP configuration, right? So this is what we configured. So we put in router BGP 100, we put in this command, right? And then we went inside address family IPv6 and we put in this activate command, right? We activated the neighbor. But you see, this section has come on its own. We did not do this, but it came on its own. The reason being, IPv4 is the default address family. So the router went in and automatically configured a no neighbor on this one, right? So you can see here, right, for any of the address family, you can see the address family, though it is IPv4, the neighborship can be formed over v6 as well. That's what I was telling earlier, right? The underlay, the neighborship can form either on v4 or v6, right? It all, on either of the foundations, you can go and then later exchange, again, any kind of routes. So that's pretty flexible. That being said, we want to do what we call as, in this at least starting segment, we want to do what? IPv6 over IPv6. That is, our underlay is going to be IPv6. What we are going to exchange also is going to be IPv6. So we are completely, we are getting rid of IPv4. So that's why nothing is happening on IPv4. We are just going to concentrate on IPv6 here. All right, so what do we do next step? Go to switch 3, right? We already have the IPv6 stuff. Let's also get the show CDP neighbors, but technically it is not needed. Why? Because let's look at the configuration, right, of the interface which is connecting R3. Show run interface Ethernet 0/0. It's nothing but a L2 interface. If you want to look at the SVI, you can look as well. Show run interface. Okay. That's what we have. We have a link local and we have a IPv6 address. So how do we get started here? Again, router BGP, but this time here it's going to be 300. Okay. Before we go to address family, let's enable the neighbor, right? The neighbor is going to be R3 in our case, and that's nothing but we'll just grab this guy only till here, and we're going to put it down here, put a :3 here at the last, right? And then remote AS. What is the remote AS? It's going to be 100. And then we'll do address family IPv6 unicast, right? And then we'll again grab the same neighbor and we will activate it, because without that, did I do something wrong? Okay, I missed an N at the start. There we go. There we go. Activated. So we've activated. Now within few seconds, your neighborship should come up, right? Let's just double check if we are able to ping the neighbor. There we go. It's already come up. So we don't even have to double check, because you see the BGP neighborship has come up, correct? So now that the neighborship has come up, you can run some commands like do show BGP IPv6 unicast. Did I do something wrong? Unicast summary. Okay, unicast summary. Okay, so you see nothing came up in unicast because there are no routes exchanged, right? We have not enabled any routes. We have just brought up neighborship. But you can see when you do a unicast summary, you can see that it is up, right? The neighborship is up. Right, the adjacency and the neighborship is up. Cool. So now let's get to probably advertising one of the routes. Right, we have a loop back here on switch 3, don't we? Let's go top. Yeah, there you go. There is a loop back here. Right, this one. So let's actually grab this one and let's advertise it in this particular in this particular BGP process. Right, so let's do network. Let's grab that address, and it's a loop back, so it is /128. Okay, now that I did that, I can go back to R3 and I can, there we go, right? Do show BGP IPv6 unicast, and you can see that route which I just now enabled on switch 3, right, was sent to us. So what we did literally was we exchanged v6 routes over a v6 underlay session or v6 BGP session, right? Very plain simple stuff which we started with. We'll do more complicated stuff later, but right now v6 over v6, right? All right, cool. So now that you see that, I mean, you know all the basic stuff about v6, right? Whenever you see this star, it basically means that it's a valid route. If you see this nice arrow mark here, it means that it's the best route, right? So that's a typical BGP stuff. What do we do next? So we have brought up the connectivity between R3 and switch 3, right? If you want, we can also probably look at, we can try to do a ping as well, right? Let's see, this is the route, this is the loopback of switch 3. Do ping, there you go, works. We can also check the routing table, right? So, because whatever we are seeing here on the top, this is our BGP table, right? So, but routing table, how does it look? Do show IPv6 route. And okay, we can just do show IPv6 route BGP just to see the BGP route. There you go, BGP route. Observe the next hop here. Okay, the next hop is FE. Where are we on FE? Give me a second. Yeah. Okay, I'm back. Okay, so we were checking the next hop, right? So this is the route, right? And you can see the next hop is FE80::9, which is the link local address, right? Link local address of what? Switch 3, right? Because it is the next hop. But you see here, if you go top, little bit top here, if you see in the BGP table, the next hop for the same route is actually the global address of what? Of my switch 3, right? So though here it is the global address, but in the routing table you can see the next hop is nothing but the link local, right? And you can also probably do a check, do show, probably we can also do something like we can check it on the CEF table if you want, right? For the same route, if you do show IPv6 CEF, you should get that, right? And the next hop you can see this is CEF table is nothing but the forwarding information base, right? It is basically the entry which is hard coded into the line cards or whatever, right? And so you can see that's exactly what we see here, right? So yeah, so that's mainly what we started with, right? Like I said, we exchanged your v6 route over a v6 session. All right, so maybe we can check probably one more important command, which is your do show BGP IPv6 unicast neighbors, right? And you'll basically see all the neighbors down here and all the information. But I think something very important for us to is the address family. So if you go on the top, you will basically see that the address family of IPv6 has been enabled, right? And you can see the switch 3 as the neighbor, and you can see that address family is advertised and received, right? A lot of other information down here to see the messages and all of that, but yeah, we'll just reserve to that. Okay, so that's good. So what we did is we did R3, R6, which was the eBGP. Next, let's do the other side, which is switch 3 and R6. Okay, so again, let's come to switch 3 probably, right? And how do we do the so this time what we'll do is slightly differently, right? So we did using the global addresses last time, right? We did using the global addresses, and we saw that the global address itself was the next hop as well, you know, on the, at least in the BGP table, but then it changed to link local in the routing table. But this time when we are exchanging, or we are sorry, this was the network command. Let me go top, yeah, over here, right? So this time what we are going to do is we're not going to use global, rather let's use the link local, right? So for link local, let's grab the link local. What we are trying to do is with the switch 3 and R6, okay? So where are we connected to R6? On Ethernet 0/1. And on Ethernet 0/1, do we have something? Let me see. Yeah, it's Ethernet. It's Ethernet 0/1, but it's all L2 links, right? So the stuff which we need to be worried about is VLAN 69, right? So that's the VLAN which is basically running on Ethernet 0/1. I can actually show it to you, right? So if you do show run interface Ethernet 0/1, right? You see it's 69 because it is this one, this link. Okay, and for 69, let's go again to the top and find what is the link local address. Again, let's come here. Yeah, 69 VLAN 69. This is my link local. So my peer is going to be ::6. That's how I've configured it, right? Cool. So let's actually come one step back. Let's do neighbor, right? Put in that link local of my neighbor. Okay. And there's a very interesting way you can put a percentage, and then you can put the interface, the outgoing interface, right? In my case, it is what? Sorry, not this one. The outgoing interface is VLAN 69, right? But you shouldn't have a space, I believe. Let's remove that space. So that's the outgoing interface, right? And then what I'm trying to do, I'm trying to establish eBGP between switch 3 and R6. So this is the L3 SPI interface, right? Over which we have to peer. And let's do remote AS again 100. Okay. Unable to configure. Did I do something wrong? FE80. Okay, so maybe the spelling. So it's very important that we follow the exact spelling when we do this. So let's grab that from the top. Okay, so it should be like this, right? So let's grab that and let's come down. Okay, so let's try that again. Okay, so let's grab that. Okay, cool. Paste it. Okay, that went through. See, the spellings are very important when you're doing it this way, right? So you can use a percentage and then put in the outgoing interface. So you see, this is a very nice, easy format to do this, right? Cool. So we have put in the because link local, right? Whenever you're using the link locals are specific for a particular link or a segment, right? So you need to tell the switch or the router that which this link local is being used on which interface, right? We want to use it. So that's why you need to mention the interface as well. Okay, so we just did that. We'll go into address family IPv6 unicast, and we need to activate it just like I showed you earlier. So let's grab that, copy it, and we're gonna activate it. Okay, so that's the stuff on switch 3 side. Let's get to what on the other side, which is R6. Okay, on R6 we don't have anything, so let's start from scratch. Let's grab the show CDP neighbors and show IPv6 interface brief, right? And let's get the configuration going. So we'll say router BGP, but this time it is 100 because that's the AS number. What's the neighbor going to be? We are going to peer it on what? Ethernet 0/1. So we'll grab this guy, but remember it's not 6, it is 9 because we are putting the link local of the other side, which is switch 3. We're gonna put the percentage. And then what's the interface? Ethernet 0/1. Again, you can't use the short forms, you have to use the whole thing. Put that whole thing, and then we're going to put the remote AS, right? But the remote AS is 300. Okay, the same thing, address family IPv6 unicast, and inside that we will again go grab this and activate it. Okay, so now you're obviously gonna get some trace tracks of this sort. I think it's something to do with the IOL images, but nothing to worry. You can see the neighborship come up, right? You can just safely ignore those. Okay, so we are on R6. What do we do? Let's see if we got the route, the loopback of switch 3. Let's see if we got that. So show BGP IPv6 probably unicast, right? And there you go, we have got it. Okay, so yeah, that's pretty cool. All right, so I'm just waiting for a couple of minutes because I did not see the arrow mark here, but I just had to wait for a few seconds. You see, did not appear, but once the BGP converts, you can see it is appearing here, right? And technically I should also be able to ping the loopback from here, which is nothing but do ping. There you go, right? Works. But observe here, the BGP table itself has the next stop as the link local, right? When compared to what we had in R3, in the R3, the BGP table was showing what? It was showing the global address as the link, as the next stop, right? Because we had paired it using the global address. But here, since we paired it with the link local, the next stop is already appearing with the link local over there, right? And obviously the routing table and also the Ceph will show with the same thing. Okay, so that's a small detail, which you can keep in mind. Okay, cool. So that's good. We are happy with that. If you want, you can also look at the routing table here as well. Show IP route. Sorry, not IP. IPv6 route BGP, right? It's the same thing. You can see here the route is here and the link local is here. Cool. So we are happy with the whole eBGP part. Let's now concentrate on the iBGP. So for iBGP, let's start with R3, R4 over here, right? And they are connected on the Ethernet 0/0 link. So let's get to what? R3. Let's start with R3. All right. So for R3 again, let's see what is the we want to see the network, don't we? So we gotta see show IPv6 interface brief. We know that it's on Ethernet 0/0. So this is going to be the network, right? So I can just go one step back because I'm already inside the router BGP configuration. I can do neighbor. We'll do it on link local itself, right? So link local ::4, because that's going to be the link local address of R4. Put in a percentage mark, right? And we'll put the interface, which is Ethernet 0/0, right? And then the remote OS, and it's 100 because it is iBGP. Remember, it's iBGP, not eBGP now. Cool, so that's good. Again, we got that trace track, which is fine. Let's quickly jump on to the other side, which is R4, right? And here, okay, looks like it's lost me, so let's disconnect and connect it back. Okay, so what do we have here? Show IPv6 interface brief. We know that it's on Ethernet 0/0. So let's get started. Let's start with the router BGP 100. Okay, and neighbor command, right? And it is basically the FE0, but ::3, and we'll put that percentage which is needed, right? And we'll put in the interface, which is Ethernet 0/0, and remote is, right? And it's 100. Let's also get into the address family, IPv6 unicast, and inside that, let's go and activate it. Right? Hope I activated it on the other side. Did I? On the R3? On the R3, yeah, there you go. See the mistake. I have not activated it, right? So I'll have to do the same thing. Never forget activating it. So you gotta get into that and come in here and gotta say activate. Okay. So once you activate, it takes few seconds. There you go. The neighborship is up. Okay. But there's something interesting which I want you guys to observe here, right? So on R3, everything was fine. R3 was able to reach the loopback of switch 3, right? But on R4, let's look at what? Let's look at the BGP table. Do show BGP IPv6 unicast, what you see here is you don't see that arrow mark, right? Which means this route is basically not a valid. I mean, it's valid, but you can't really reach. Why you're not getting the arrow mark here is because of this, because of the next hop, right? So what we did just now is we did IBGP. We go back to the diagram here. This was eBGP, and now R3 and R4 we did IBGP, right? And one of the main law of IBGP is what, right? That your the next hop doesn't change. So whatever next hop this guy is getting, which is what the next hop is switch 3, the same next hop is basically sent down here, right? When the route goes from eBGP to IBGP, the next hop is not changed. But then when R4 receives the route, it really doesn't know the address, right? It doesn't know the next hop, right? This next hop is really not reachable on R4, and as a result, that route is not valid or not basically best, right? You're not getting that arrow mark. There are different ways to fix it. Let's actually look at a couple of interesting ways to fix this, right? So one way is basically what we can do let's go back to R3, right? So let's go to R3 and let's look at this link between R3 and R4, which is Ethernet 0/0, right? Show run interface Ethernet 0/0, and you can see it's running IPv6. It's running IPv6 OSPF. Okay. So what I can do is I can basically take this link, right? This link, because R4 doesn't really know about this link right now. That's the problem, right? So what I can do is I can take this link, right, directly connected link, and I can redistribute into OSPF so that R4 comes to know about it. That's one way of doing it. Not a very good way, but just one way. So I just want to show it to you that it works that way. There's obviously a better approach to this, but I just want to explore a couple of ways. Okay, so OSPF 1 is here. So what I'm going to do is I'll get into OSPF 1. Okay, and I'm going to say, I got to do IPv6 router OSPF. OSPF 1, I guess. IPv6 router OSPF 1, right? And then I'll do redistribute connected, right? So once I do this, as soon as I do this, if I come back to my R4, right, earlier you see the route was not valid or it was not reachable, but now, okay, it's gonna take a few seconds. There you go, right? Now it's reachable. Why? Because R4 can reach the next hop now because I redistributed it, right? Obviously not the best way to do it, so that's why let me actually remove this, right? Let me remove that. So once I remove it, obviously better to clear it just to prove to you that it has been removed. So what I can do is let's clear the BGP IPv6 unicast star inbound, right? So once I clear the BGP, if I go back to R4, right, we are back to the older state where it is, where you don't have that arrow mark, right? So what's the option number 2? Most of you guys might know it. It is using the next hop self. So on R3, what I can do is, again, let's go back to router BGP 100, address family IPv6 unicast, right? And wherever that, this is the neighbor, right? So, so wherever I've defined the neighbor, which is basically R4, what I can say is, now whenever I'm sending my routes, whenever the eBGP routes are going from eBGP to IPGP, I want you to change the next hop. Point the next hop to yourself, right? The next hop self. So once I do that, right, let's go back to R4. Let's see if that helps. Not yet. I might need to again clear it, maybe to do it a little quicker. So I can use this command to clear it, right? I'm clearing the BGP, going back to R4 again, and not yet. Okay, let's wait. Yeah, there you go, right? So you've got the arrow mark now, which means the route is valid, and you can see the next hop is now changed to the link local of R3. So R3 basically changed the next hop to itself and sent it down, right, to R4. Okay, so that was pretty useful, right? But at the same time, we have seen on R6, have we seen it on R6? we have seen that we paired it with link local at the top, right? So we'll see some interesting issues coming out of R6 as well. But okay, so let's do it step by step. So what we did right now is we have done the eBGP on both the sides at the top, and we did the iBGP between R3 and R4. Next, let's concentrate R5 and R6. Okay, so let's do R5 and R6. Okay, so for R5 and R6, let's start with R6, because we already have something on R6, don't we? Right? So R6, remember, if we go back to do show run section BGP, if you have forgotten what we did, we kind of paired it with switch 3, but we did it using the link local addresses. Okay, so how do we handle this? So what we're going to do is we want to pair it now with R5, right? So let's see, do show IPv6 interface brief, and for R5, what do we do? Where is R5? For that you would need the CDP neighbors. So my R5 is connected on Ethernet 0/0, so that's the one, right? This one. So let's go one step back. Let's enable the neighbor. It's going to be, obviously, let's do it with the link local again, right? This is going to be R5, so let's use the percentage. Let's use the whole interface. Yeah, it's Ethernet 0/0, correct? And then the remote AS, which is 100. And yeah, there you go. The traceback is going to come, but the neighborship will not come up yet because we have not done anything on R5. So let's get to R5. So on R5, okay, enable, let's clear the screen a little bit. Okay, so on R5, again, we don't have anything. So let's do show CDP neighbors and do show IPv6 interface brief. That's what we have. So let's start by router BGP 100, right? But this time I want to introduce you to one interesting command, which is, like I said earlier, right? BGP uses IPv4 as the default address family, right? So we will fight that behavior, right? We'll kind of nullify that behavior. How do you do that? Just by putting no BGP IPv, which one? v4, right? That's it. Is it? Oh no, my bad. No BGP default, right? Default IPv4 unicast. Yeah. So by doing this, what we are telling is, look, BGP, no longer consider IPv4 as your default address family, right? Pretty useful command, and I'll show you the difference once we finish configuration, right? Cool. That being said, let's do our regular stuff. Neighbor, and we are connected to R6 on Ethernet 0/0, so it's this one, but obviously it's going to be 6, and we'll need the percentage. Let's grab again this part, right? And here, and then what? Remote AS is what's the remote AS? 100, isn't it? Okay. Don't forget the address family, IPv6 unicast, and you would still need to grab that and activate it. Okay. Hope we did the activate on the other side. Did we? On R6. On the R6 side, oh, we did not do the activate again. See, we forgot. So it's address family, IPv6 unicast, and we will grab that and we'll activate it. Right, so now the neighborship should come up. Now there's a traceback, that's fine. There you go, the neighborship is up. Let me quickly show you the difference, right? So if I do, okay, so I have to show you the difference on R5 because that's where I put that no BGP command, right? So if I do show run section BGP, right? What do you see here, right? Let's actually compare this with probably some other device, say R3, and let's compare the output. If you see the output here, you can see that the router itself has added these two commands, right? It has added this no neighbor activate, no neighbor activate for switch 3 and for router 4, right? It has added under IPv4 because IPv4 is the default address family. So it has gone and explicitly disabled the neighborship on neighborship for exchanging IPv4 routes on these two neighbors. But on my new router, which is R5, since I disabled it, right, explicitly disabled it, you see that that section is not there, right? So we literally told the router, look, don't give preference to IPv4, don't consider IPv4 as your default, so as a result, the router did not go and put that. So that's again a small detail if you really need that. Okay, coming back, so the neighborship came up, didn't it? Right, we saw that neighborship come up on R6, we saw it here, right? But let's see what is happening here. If you do show BGP, IPv6 unicast, right, you will not see anything, right? There are no routes at all. Why is this happening, right? The reason is, if you go back to our diagram here, right, so this is what we have, right? So we did this part, right? We did this IBGP. We are concentrating on this one now. Grab that. So this is what we are trying to do, right? And if you remember, what we did was we kind of used the link local to form the neighborship between these both. Okay. So the next hop for the route, the loop back here, right, whichever is there, the route when it arrived on R6, the next hop was the next hop of this guy, right? And then the next hop basically the link local address of switch 3. Now that route, when it came down here, right, it still had the same thing. Again, the same reason, because IBGP doesn't change the next hop. So it had the same link local address, right, of the switch 3. And when that route came to R5, the R5 really doesn't know about this link local, because the link local over here is kind of local to only this segment. So as a result, the route was not even installed, right? So obviously, easiest way to fix that would be what? Next hop self, right? We looked at two ways earlier, but let's use the simplest way, which is next hop self. So let's get to R6 here, right? Because R6 is the uplink router, the top one, right? So here, when the neighborship is activated, right, along with that, let's say next hop self. Okay, so we did that. Let's come back to R5 now, and this time take few seconds. If it doesn't, we know the command to clear it, right? Not yet. So do I have a clear command here somewhere? I don't want to type it again, so yeah, there it goes. So we've got the clear command, so let's grab that. Let's give it one more try. Did it come? Oh, it's already come. I did not have to clear it. There you go, right? So as soon as I put in the next hop self on R6, you can see that route has arrived here, and you can see even the arrow mark which is available, because now R6 is putting its link local address and sending it down to R5, and R5 knows about this, right? It knows about this because I can ping it, right? I can show you that. So I can grab that, put in that, and which is the interface. We are doing this on Ethernet, I think it's Ethernet 0/0, right? This one, right? So I can go and there you go, it's pingable, right? So basically that's the reason earlier the route did not appear, but as soon as I change the next hop self, it's here. Okay, so that's that's mainly the stuff which I wanted to show you guys, right? With the very basic, IPv6 BGP, where we did basically BGP on, right? We did the IPv6 on IPv6, right? We exchanged IPv6 routes on top of on top of what? We did it on top of the IPv6 sessions, right? So thanks a lot for watching, guys. We'll come back with more. Okay. So continuing from where we left off, right? What we did was, till now we have configured BGP, where we exchange the IPv6 routes over IPv6 neighbors. The next part we are going to concentrate is, we are going to do IPv6 routes, that is exchange IPv6 routes, but over IPv4 neighbors, right? So BGP is pretty flexible in that aspect, that it allows us to actually do that, and we'll check that out. Okay, So what I've done is, coming into this section, I have removed the BGP configuration which we put in the previous section, which is I've removed BGP from all these 3 devices and these 2 devices, right? So it's completely fresh. Okay, so let's come back here. So let's get to R3, right? And what we're going to do is we're going to do the same thing which we did in the previous section, where we will go to router BGP 100. Okay, and we don't want IPv4 to be the default address family. We don't want it to be enabled also. So as a result, what I'll do is I'll say no BGP default. I think it is default what? IPv4, right? So by doing this, we are basically telling BGP not to send this IPv4 address family, which is otherwise enabled by default. Okay, so that being said, let's get to our neighbor, right? And like I said, in this section, what we are doing is we are concentrating on, just to double click here, we are concentrating on IPv4 neighbors, right? The neighborship is going to be established with IPv4, but we are going to send IPv6 routes on top of it. Okay, so coming back here, neighbor. So what will be the neighbor, right? So the neighbor is the switch 3. So if you go down here to switch 3, and this time if I do show IP interface brief, right? So this is my neighbor, IPv4 neighbor. So I'm going to grab that guy, come here, right? And what? Remote AS is going to be 300. All right, cool. And then obviously we got to do the address family, IPv6 unicast. So nothing changes here, right? Very similar to the configuration we did in the previous section. And we have to activate, right? Only difference is this time we are not using IPv6 neighborship. We are not using IPv6 neighbors. We are using the addresses, the IPv4 addresses, to form the underlay. And we'll see how we can exchange the v6 routes on top of it, right? Just let's have a quick glimpse of what we did, right? Section BGP, and you can see this is what we intended, and then you can see the neighbor with the IPv4 address. You see v4, there is nothing under it because we have disabled it because of this command, right? There is nothing being sent as part of v4 family. And then under IPv6 address family, we have the activate command, which is perfect. Let's also see the TCP, right? What TCP are we actually listening to, right? Because whenever you enable BGP, you do know that it uses that port 179, a TCP port 179, right? There you go. And you can see, but the neighborship this time, the neighbor address is a IPv4 address, and it's in the listening state, right? Perfect. Coming to switch 3, right? That's on. So on switch 3, let me clear the screen. One sec. Okay, so let's get to business here, right? It's going to be again router BGP, but AS number is going to be 300. Let's do no BGP default IPv4, that is removing the v4 address family, because we are not going to be exchanging v4 routes, at least in this section. And then we will enable the neighbor, which is going to be what? 50.1.39.3, because it's the R3 with whom we want to peer, and the remote AS is 100, correct? And then what? Let's get into address family, IPv6 unicast, and we will have to grab this address and we'll have to explicitly activate it. Okay, so now at any moment we should see the neighborship come up, right? Let's quickly see. Do show run section. Okay, there we go. We don't even have to see because the neighborship has already come up, right? We can see here the log is seen. Okay, but let's look at the BGP table. Before we look at the BGP table, let's actually advertise some network inside this routing, right? What we'll do is we'll advertise the loopback which we have. What is a loopback? Do show IPv6 interface brief, probably. Yeah, there you go. That's the loopback which we have, and I want to advertise that. So I'm going to say network. I'm going to put that, and what is the mask? It is going to be 128 because it's a loopback. Okay, so I've advertised that. Now what we'll do is we'll say do show BGP IPv6 unicast. So let's look at the BGP table, and you can see that route is available here, right? And obviously switch 3 is able to reach this route because it is directly connected. It's on the same device, so you can see everything looks good from this side, right? But let's see what is going to happen if I grab the same thing and put it on R3. What's happening on R3? Here you can see the route is visible, right? The loopback of switch 3 is visible, but it doesn't have that arrow mark, right? The reason is because, why is this happening? Observe the next hop. What has happened here, right? So this is a very special address. I think we call this as mapped IPv4 address, right? You can see what it does is it puts the double colon, and then it puts FF, the 4 Fs, and then it attaches the neighbor's IPv4 address, right? This is the IPv4 address of switch 3, right? So that is the next hop, right? That's the next hop, which is basically sent by my switch 3 when this route is, advertised to me, right? But what is happening is this address really doesn't make much sense if you are not doing something like MPLS. And if you do MPLS in future, maybe we can have a look at that, in which case, because in MPLS the routes are forwarded based on labels, right, and not on the routes itself. I mean, the packet is forwarded based on labels and not on these addresses. So as a result, we can still use this address and the router basically can forward packets. But in this case, since we are not running MPLS as such, if we actually go and do the same thing, but this time provide this whole thing, right? Let's look at in the BGP table, let's get more details about this route. You can see that it is telling this next hop is inaccessible, right? So R3 is not able to understand what this address is, right? As a result, it is telling inaccessible, and as a result, you can see that that small arrow mark is not present here, which basically means this route is not reachable as of now. Now, like I said, in MPLS, if we do that MPLS in future, we'll probably look at how we can mitigate this. But for now, the quickest way to mitigate this would be to use a route map, right? So let's come to R3, and what we're going to do is let's create a route map, and I don't know, we can give any name. I'm going to say route map, I don't know, maybe to R3, right? R3, okay. Let's use capstar to R3, and I don't know, maybe V6, right? So that's our route map. And what we need to do here is I'm going to set the next hop, right? I'm going to say set IPv6 next hop, right? And set IPv6 next hop, and what is going to be the next hop? 1001:db8, right? That's the IP address of 139::9, right? So I'm basically setting the next hop as switch 3's IP address, the global IP address, right? And once you do that, we'll have to obviously use that router BGP 300 inside the BGP configuration, right? So where do we use that? Get into the address family IPv6 unicast, get into the neighbor. What is a neighbor? 50.1, 39.3, and this is the place where we can use that route map. Let's use that route map. Okay, did I make a mistake? Okay, so I can just put a space here, route map, and in which direction? Out direction. There's a mistake. I think I need to write the whole thing, so let's write route map. Okay, that looks good, right? So we are basically telling that when you are peering with this neighbor, which is R3, use this route map. And in this route map, what we are doing is for all the routes which I'm advertising, I'm basically setting the next hop as myself, right? Which is the actual IPv6 address, because the address which is generated by the router, which is like a mapped IPv4 address, that is really not accessible by the peer, right? At least in this, when we are not running any MPLS network, it is unusable address. So to get around that, we have created a quick route map and we have attached it, right? Now let's quickly clear our BGP. IPv6, I think it's unicast, right? Star and out, right? There you go. So I've cleared the BGP. And if I go to R3 now, right, see, earlier we had this whole issue, right? Now let's run the same command. What's going to happen? There you go, right? We have what we want. We can see that, in the BGP table, it's getting this as the next hop, right? But obviously in the routing table, it would have, it will basically use the link local, right? So we have seen that before. So we can again have a look. Do show IPv6 route BGP, right? There you go. So it is using FE80::9, which is the link local address of the peer. Perfect. We can also probably have a look at this command where it was showing inaccessible earlier, right? Where is that? It's basically nothing but, let's go top. I think it was this one, right? So we can grab the same command and plug it in again, and you can see this time it is using what? The FE80, and you can see there is nothing mentioned as inaccessible anymore. Okay, so that was a quick way to fix this, right? Basically what I wanted to show you here is that you can actually let's look at the configuration maybe on the switch 3 side, right? So the final configuration is show run section BGP. You'll basically see that you have the router BGP, the IPv4 has been disabled, right? Address family of IPv4 has been disabled because right now we don't want to advertise IPv4 routes. The neighborship has been formed with using an IPv4 address. See, these are two different things, right? Forming a neighborship is different and exchanging the routes is different, right? So we are not exchanging v4 routes, but at the same time we are forming the neighborship with the v4 address. And you can see under the IPv6 address family, we are advertising the network which we want to advertise, and you can see the neighborship has been formed using v4, right? This might look little interesting for you because you might be confused. How are we doing this? I mean, you have the address family of v6 and you're forming neighborship, but yeah, that's the beauty of BGP, right? You can do that. The underlay can be anything. You can use v4, you can use v6, and on top of that you can exchange any kind of routes, right? And you can see we have also used a route map because we saw that there is a small problem with the next hop. As a result, to get around that, we have created a route map and we are explicitly sending the next hop so that the router is not confused with that weird IPv4 mapped address. Okay, so that finishes off which one? The second section, which is exchanging IPv6 over IP what? v4. Alright guys, so we are heading to the final section, which is exchanging IPv4 routes over IPv6 sessions, right? We have talked about the first two already. This is going to be the last one. Okay. Yeah, let's get started. So we'll jump onto my R3 here. I've cleared out all the configuration which was done in the previous sections, which means we are starting fresh. Router BGP 100. Okay. And what is going to be my neighbor? My neighbor is going to be my switch 3. So let's go to switch 3 and we can probably run do show IPv6 interface brief. So what is it going to be? It's going to be this guy, right? VLAN 39. So I'm going to grab that and I'm going to say remote AS 300. All right. And then obviously you need to get into address family, but which address family? I'll obviously use IPv4 because that is what I want to exchange, right? So I'm going to say IPv4 and unicast, and we will grab this guy and we will say activate. Okay, looks good. So that's all from the R3 side. Let's jump on to switch 3 now. Okay, let me yeah, so here it's going to be again router BGP 300, and the neighbor is going to be the same one, but we will end it with what? 3, right? Because that's R3, and remote AS is going to be 100. And we will also get into the address family, but IPv4 unicast, and we will grab this one and we will activate it. Okay, and within few seconds the neighborship should come up, and while the neighborship is coming up, let me also go and advertise, right? See, the neighborship is already up. So what did we just now achieve? We established the neighborship over IPv6, right? So the BGP session is over IPv6, but now we are going to exchange a IPv4 route on top of it. So I'm going to say 10.9.9, which is the loopback of IP address or IPv4 loopback of switch 3. I'm going to give the mask, which is going to be /32. All right, cool. So let's see, let's do show BGP IPv4 unicast, and there you go, the route is there. It is under the BGP IPv4 address family. This is the route. Can we also see the same guy on the other side? You bet. There you go. You have it. But now, what's interesting here? Can you spot it? Right? The situation is that you see this next hop. This IP address is nowhere in our topology. Then how did it come here? So how did it come here is basically the neighbor address, right? Or if I do something like do show TCP brief all, right? This will also show my neighbor IP address, which is same as nothing but this one, right? 39::9. So this address is basically a unusable address, right? I don't know why they even came up with this as next hop, but it's basically unusable, right? It's nowhere there in my topology. So how are we even coming with this addresses? It basically picks, for this one, it basically picks, the first, I think 32 bits, right? And it converts into basically the first, the network portion of this IPv6 address, right? What I mean to say is the first 8 bits are what? 2 and 0, right? So 20 in binary, if you convert, right, you basically get nothing but 32, right? So 20 is what? 0010 and 40. So if you put it together, those 8 bits, you basically get the 32. Then you have the 01 here. That's nothing but this guy, right? And then you have what? 0D, right? There is no 0 mentioned here, but you need to assume there is a 0. So 0D is nothing but 13, right? D, if you write it in binary, you basically get nothing but 13, decimal 13, okay? And obviously the other one is B8, which you get nothing but the 184, right? So basically it's nothing but these 32 bits, right, which are basically restructured, or basically they are converted into decimal and displayed here. But this address is of no use for me, right? And that's why you see there is no arrow mark for this route as well, because this router also doesn't understand this address, okay? So obviously, again, I'm just trying to stress here, because this is again goes back to the same thing which we discussed in the previous section as well, the whole issues with the next hop, right? So the only way to solve it is by using our route maps, right? So maybe let's do it for one of those guys. So let's do it for this one. So I will have to create a route map. Let's call this route map what? Maybe something like route map to R3, and I don't know, maybe version 4, right? And we'll set the next hop here, set IP next hop, and the address is going to be 50.1.39.9, right? So I'm basically putting my own address, which is switch 3's address, as the next hop, right? And when I hit the enter, there you go. So that's the next hop which I have set up. So now I'll have to go inside my BGP, which is 300, and I will have to get into the address family, IPv4 unicast, right? And where is that? Yeah, this is a neighbor, right? So I'll have to get into this neighbor, and I'll have to explicitly say route map and use this route map, right? So now I'm forcing, okay, route map in which direction? Out direction. Okay, so now I'm basically forcing, let's clear the BGP once, do clear BGP IPv4, right? Because we have IPv4 address families. I'm going to say unicast star and out direction, right? So I've cleared the BGP now. Now if I go back to my R3, and if I probably run do show IPv4 unicast, you can see the arrow mark has come, and you see the next stop has changed, right? The reason is because I put a route map here, and I explicitly told that whenever the routes are basically sent out, use this as the IP address. Okay, so this solved our problem. Now you see this guy, this next stop is reachable, and that's why I can even ping this one, right? I can ping it. Cool. So yeah, so that's mainly it right here. I mean, you can also probably, if you want more information, you can see do show IP, and probably put in the route, which is nothing but 10 dots, right? You can see the next stop clearly mentioned, right? But basically what I want to stress here is that when you are using different underlays, right? I mean, if you're using, in this case, we are using the underlay, or the BGP sessions are formed over IPv6, and you're trying to exchange IPv4 routes, there will always be a problem with, you know, the next hop, and then you'll have to solve it this way by putting some kind of a route map on something like that. Okay, cool. What we'll do is next, let's try to do the same thing what we did here between R3 and switch 3, but let's do it with the link local addresses, right? We use the global addresses to form the neighborship just now, which is this one, but this time between switch 3 and, so let's get to switch 3 and R6, right? So we will create a, let's go back once, let's say neighbor, and what is going to be my neighbor? R6, so let's get to R6. Here I'm gonna say show IPv6 interface brief, and what is the address? So it's going to be this one, right? So because it's the Ethernet 0/1, that is the one which is connecting. If you see here, Ethernet 0/1 on both the sides. Cool. So I'm on switch 3, right? And I'm putting the neighbor address, which is going to be FE80::6. And you'll have to use the percentage if you want to reference the interface, right? So in my case, the interface is going to be VLAN 69. So that's the SVI which I want to use. So I'll have to put that if you're using the link local addresses, and then put the remote AS 100. And then the same thing, address family IPv4 unicast, and grab this whole thing, activate it. Okay, so that's all on the switch 3 side. On the R6 side, right, this is my R6. Let's get into this. I'm gonna say router BGP 100 neighbor. But what's the neighbor going to be? It's going to be nothing but ::9, right? And percentage would be, the interface is nothing but Ethernet 0/1, and remote AS is going to be what? 300. Okay. Address family again IPv4 unicast, and I will have to grab this whole thing and activate it. Okay, so we did the exact same thing what we did before, right, between R3 and switch 3, but this time we use the link local address. Okay, let's see the behavior. What behavior did we observe earlier between R3 and switch 3? We at least got some kind of a in the BGP table, we at least got a route. Yes, the route was not reachable, or basically you did not get the arrow mark here, but still it was visible, right? But you would see something different in this case, right? So if I go to say R6 and see the neighborship is up, right? But if I do show BGP IPv4 unicast, okay, see, nothing is there. If you want to see the configuration once, we can have a look. There's nothing wrong with configurations, right? So you have the neighbor mentioned here, and then under the v4 you have activated the neighbor. Okay, so you don't really have maybe let's actually put in, probably let's advertise. Have I not advertised? Okay, I've also actually advertised on switch 3, right? Let's go to switch 3. Do show run section BGP, right? If you see here under IPv4, I've advertised this network, but that network is not even showing up on R6, right? You see here it's completely empty. Do show BGP IPv4 unicast, it's completely empty. The reason is, right? The reason is pretty simple. What is happening is same problem as earlier. Let's actually now to explain that, let me actually do show TCP brief on, right? Why this problem is, why is this problem even happening is because when you see the output of this, you will basically see the BGP peer, right? Or basically you can see here also, right, the neighbor FE80::9, right? Now as per the same, see even here also it shows the same neighbor, right, basically in the TCP table. But whatever it is, it uses the same logic to find the next hop. Now in this case, when it tries to find the next hop, FE, right, if you convert this, I think it is 254, right? And 254 is not a valid IP address. I mean, I don't even know why they, I mean, there are some special reserved addresses, right? I can't even think of a class, right? It's all in that range, right? 254, it's not a commonly used IP address. So when it sees a address of this sort, it is not even installing that route in the routing table. At least in the previous case, the address was something like 32, right? And it at least installed it. But whenever it sees something like FE, right, that's sure not going to be installed. And again, to fix this is pretty simple, like how we did earlier, right? We'll have to just go to switch 3, put a route map and send the next hop explicitly. But I will again not fix this because there is no point in fixing, because we already showed that, right? So let me go and remove this routing process from R6. Okay, let's remove it, and on switch 3 what we'll do is, so we kind of had a look at this, right? I mean, we had a look at this. We saw even while doing this last method, we are still going to have some kind of next hop issues, and a simple way to solve it is using route maps and setting the next hop. But we'll see that we can still work with this when we are doing MPLS and so on. But for now, a simple quick way to fix it is using route maps. The other thing which I probably not listed here is, or maybe we can consider it to be a extension of the same topic, is using something like a dual stack, right? So when I say dual stack, what I mean to say is, let's actually do that. Let's actually do the configurations as we talk about it, right? So let's do it from where? Let's do it on switch 3. Okay, so on switch 3, what do we have as of now? We have these two nice neighbors, which is, we forget about the neighborship between switch 3 and R3. We are just talking about, for the rest of the video, we are just talking about switch 3 and R6. Okay, so switch 3 and R6, there is one neighbor which is a V6 neighbor, right? What I'll do is, let's also put one more neighbor which is the V4 neighbor. So that is going to be 50.1.39. Because we're talking about switch 3 and R6, right? So it's going to be 69.6, correct? And the remote AS is going to be 100. Okay, so there you go. So we have added now the V6 neighbor as well as the V4 neighbor, right? We are doing it separately, so we added both the neighbors. Let's get into the address family IPv4 unicast. First thing I'm going to do is I'm going to remove this neighbor, right? The V6, the neighbor which was formed using the V6 sessions. I'm going to remove that. Instead, I'm going to use this new neighbor which I just now added. Okay, and I'll get into address family IPv6, right? And that's where I will basically use this neighbor, right? The V6 neighbor. So I'm just trying to separate the V4 from V6 completely by this method, right? So something like this. Okay, and obviously I can advertise the V6 loopback as well, which is 2001:db8:100 I think it is :9 if I'm not wrong, /128, correct? So if I do a quick show run section BGP, what do you get? See, it's very nice structured, right? What do you have on the top? Forget about this because this is R3 and switch 3. This is the V4 neighborship for towards R6, and this is the V6 neighborship towards R6. And you can see inside R4 we have the R4 address kind of advertised, the loopback. Forget about these two because that's corresponding to R3. This is the V4 neighbor. We have activated the V4 neighbor for V4 address family, right? And you can see the V6 has been disabled. Whereas on the V6 side, we have activated the V6 neighbor and we have advertised it, right? So this is a very, more like a dual stack way of doing it. And let's do it the same thing on R6 as well. Okay, so on R6, see, we had removed it, so we'll add the router BGP again. The two neighbors are going to be what? 50.1.69.9. Remote AS is 300, and the other guy is neighbor. What's the other one? It's gonna be, okay, that's okay. We have removed it, so we'll have to add it again. That's the neighbor, and the remote AS is nothing but 300. Okay, and let's get into address family IPv4 unicast, and let's just activate this guy. Activate, and let's get into the address family of IPv6. And let's just activate this one. Okay, cool. So that's on the R6 side. Okay, so now if I do something like do show BGP IPv4 unicast, right? There you go. So you have the IPv4 route with the correct next hop, and if you do something like IPv6 unicast, you can see you have the v6 network and its corresponding next hop, right? There's no hassle about next hops. You can see the next hops are all nice and fine here. You don't have to do any extra route maps and stuff, right? The only downside of this is what? If I do something like do show TCP brief all, what's the downside? I think before the answer comes here, you should be getting it, right? So the downside is that you will basically have multiple TCP sessions. There will be one TCP session only for v6 and there will be another TCP session only for v4, right? So there you go, that's the v6 one, and we should also have one more which will probably come in a few seconds. That's going to be for v4. Okay, still coming up, give it a few seconds. There you go, right? So that's the v4 one and the v6 one. So you're just going to have two sessions in this case, you know, one for each address, one for each address families, neighborships, right? For v6 you're going to have separate session, for v4 you're going to have a separate session. Okay, so yeah, if you have a huge number of sessions and huge number of neighbors, then obviously the recommendation would be to kind of figure out if you can use one single session to transport all those routes. But in some simple cases like this is also well and good. I mean, if you do this, you are not going to have the issues with your next hops, right? Because the underlay and the routes being exchanged, everything is in the same stack. It's either IPv4 or IPv6. Okay. Also, the configurations looks much better. If you do show run section BGP, you will see that the configurations are much streamlined, right? So here, see, you can clearly understand that we have two neighbors, one is for v4 and other one is for v6, and you know that inside the v4 neighbor has been activated. Inside the v6 address family, the v6 neighbor has been activated, and you also have so that's mainly it, guys, right? So just to recap, what did we do in this whole BGP series was, or the BGP video was, basically we started with something very important, which is how do you exchange v6 routes over v6, right? We talked about some challenges, we talked about the whole next hop self and all of that. I think we did variants of both, right, where we formed neighborships with using the global address as well as with the link local addresses, and we did all of that, and then we moved to show that BGP is very flexible. That is, you can even exchange v6 routes over v4, and then finally we also did the other way around, that is exchange v4 routes over v6. We have obviously not done the obvious other option, which is exchanging v4 routes over v4 sessions. Why? Mainly because that is a pure IPv4 BGP and we are talking about IPv6 here, so it doesn't really suit our discussion, right? But that is obviously the other option which is missing here, which is nothing but v4 over v4. We have talked about actually that in the other videos on the channel. You can go and check it out as well, right? So thanks for watching, guys. That was mainly the BGP stuff with IPv6.